Okay, good day, students. Today, what you see on screen in the comments area from line 1 to 9, that is what we're going to be looking at. Order of operations in math. Now, I know that you should have done this in your math classes. And seeing that Pascal and programming is taught to CXC students, one would figure that you have some familiarity with this. Maybe even as early as primary school, grade 5, grade 6, coming up. So basically what I'm doing today is trying to give you an idea, a synopsis of how it works with IT. And not only that, but to remember that your data types here will play an important part in deriving your answers when you're carrying out order of operations. Primarily the term called BEMDAS, which means brackets first, then exponents or powers, then multiplication, division, addition, subtraction. That is the order in which mathematical operations are carried out. So here's the name of our program, order of calculation, BEMDAS, and we have some variables, all 4 variables, num1, num2, num3, a different way than normally you would use it, yes, trying to just create some variations with the variables, and just call it NUM, just do it this way this time, even though it's not the way I normally would use it. Might give me a little bit of a problem later on in my program, but let's see. Alright, in terms of remembering by rote learning, or just by muscle memory I should say, what you normally type. And of course they're all declared as integers, and we have here num1 hard-coded as 4, num2 hard-coded as 1, num3 therefore equals to 3. Keeping the numbers simple so we can do the calculations mentally, alright, which is also a good practice. When you're working with large numbers, writing a program, first you test it with simple numbers to see if the answers are correct. If the answers are correct with simple numbers or small numbers that we can just calculate off the top of our head, snap snap, then it will also be correct with the larger numbers. Solution or sol is what we're going to use as the variable to hold the answers as we run the program. Now let me make this clear to you. Yes, I've seen where you can use right line and do whatever. I'm not going to practice that. Not with students that I'm teaching programming. Because when you're teaching programming, you need to practice and reinforce certain habits, good habits, before you start taking shortcuts. You need to make sure you get familiar with the use of your variables. Also, to make sure you clearly comprehend the implication that data types will have on your answers, which we're going to see shortly. This video will not be too long. I know most of them go up to 15 minutes and change, never 16 minutes, thank God. But I want to see if I can keep this one under 10 minutes or just about 10 minutes. So here's what we have. We have num1 plus num2 times num3. And this, of course, is bracketed. Now, it would also help, yes, when you're doing this, remember the commutative, associative, and distributive law of mathematics. Those will help. If you don't have a clue what I'm talking about, YouTube it. But I'll give you this much because it will apply to what we're doing here. The commutative law speaks primarily to this. Addition and subtraction will give the same answer no matter which way you start the calculation. Alright? We're going to discover that a little bit later on. But here is what we have. Solution therefore equals to num1, open brackets, num1 plus num2 times 3. Num1 and num2 is 4 and 1 respectively. Why would we do these first? Because they are in brackets. What's in brackets takes preeminence, is the first calculation we'll do. So 4 plus 1, 5. Then you multiply that by 3. And then what should we get? Come on, tell me what you think the answer would be. 15. Alright. Then let's remove the brackets a bit and let us see what we get for the answer here. Move the brackets and we run the program again. We get 7, because what the computer did this time was to take note of the multiplication sign here, and then would multiply num1 times num2, which is basically 1 times 3, which is 4. 1 times 3, sorry, which is 3. Whoa. and then you add 4 to that, it becomes 7. That is how that works. So this just a simple, seamless demonstration about order of operations. But let's go a bit further. And sometimes it is good to make sure we state our problems clearly, because I once heard this term and I adopted it. I don't remember where I heard it from, but it said a clearly stated problem is half the solution. A clearly stated problem is half the solution. Let's imagine this for a moment. I want to average these three numbers. So we add them up, right? We say you add up all the numbers, then divide by 3. Alright, so we add up all the numbers, then we divide by 3. Notice I said a while ago because I was going to put this sign, divide. But then I realized that solution, the container for those numbers, for the solution, whatever answers we get, is an integer. This is a floating point division, so I'd get an error if I run it that way. Video number 4 demonstrated this, but compiling, I hope I don't lose the server. Let me just copy this just in case. Because usually when this happens, they go and tell you, oh, server error, couldn't connect to the server. I'm going around, okay, alright, fine. I might edit this out too. Let me refresh this. I copied the code already, so let me refresh it. And hopefully I'm back. I'm good again. Alright. Control A had and Control V highlight everything. So, alright. So remember what I was saying. This sol is also an integer variable. However, this divide sign means floating point division. So sol should be set to real. When I run this now, I'm going to get an error. See? So it is best if I want to get a whole number, I should use the term div. Oops, let me click back up here. I should use the term div. Oops, not dive, but div. Alright? And let's run this now. And see, our program should work fine. And we get 6. Why is the answer 6? Because I said divide by 3. So in other words, what the computer did was to divide 3 by 3. 3 into 3 one time. And then add that now to num1 and num2. So 4 plus 1 is 5 plus 1 again, which is the 3 divided by 3. That now gives me 6. As opposed to, let's look at the difference here. If I were to put these in brackets, doing a true average situation, here is what we're talking about. We're saying to the computer, add up num1, num2, and num3. Add those two first, those three numbers. So it's 4 plus 1, 5 plus 3, which is going to be 8. And then what you do is to divide that now by 3. When you divide that by 3, you know what I should do? Let me run this. Alright, I get 2 for the answer. Alright, so 3 can go into 8 only 2 times. Only 2 times. That's what div says. I could go a little bit further. Let me use the floating point division here to make it more real to persons. But then what I'd have to do is to remove this sol here and tell it that sol needs to get a floating point number or decimal number. So let me do that. And then now get back out of this. Press enter, get out of that. And let's know, oh yeah, I need to format sol so it doesn't give me some scientific notation. Colon 0 spaces, colon, let's say 1 or 2. 1 decimal place is fine. Alright, now let's run this. When I run this, this is what happens. I am really server issues again. Oh, okay. Now I get 2.7. So this now gives me the answer that I want, because you add the numbers first. What I was talking about when clearly defining a problem, if you define average as add up some numbers and then divide by the amount of numbers you add, that's not it. Inherent in that situation is the problem. You don't add up some numbers then divide by the numbers you add. The proper way to say it, to make sure you express the solution properly, is to add a group of numbers. then divide the answer or the total by the amount of number you add. So by saying that properly, you're making sure it's clear in your head. I must divide the answer that I get by the amount of numbers I add. So basically what I'm saying here is this. Add these numbers first. Tell the computer what's inside the brackets. Add those first. Then I divide by the amount of numbers I was adding. That is basically how you do it. So I know this is a very short idea, young people. It does not necessarily indicate the problems that you're going to face. No, I am not professing that I can prepare you for every scenario you're going to come across. I'm simply making you aware of order of operations. Yes, and while it's a very simplified form, remember it. Brackets, then exponents, then multiplication, division, addition, subtraction. Let me give you one other one for good measure. What should I do? Because div in its very nature too is also a problem. Because of that, the different ways to divide. We're going to do whole number division or floating point division. But let me just remove this and give something else. Let's say I want to say minus. Alright. So which one? You know what? Let me put this first. Because addition should go before subtraction. So let me go put that there. And then yes, let me do this. This will be fun. I would say this. Alright. Minus this. Put that in brackets. And then I'm going to multiply by num3, then plus num2, then plus what? No, plus yeah. Let me work with that for a bit. All right, let me work with that one for a bit. All right. So which calculation would you do first? That's what comes the answer question. No. Num1 minus num2. So num1 is 4 because it's the innermost bracket. Right? So we have to do this one first. Then we do the outermost bracket. And then we do the rest of the calculation. So 4 minus 1 will be 3. Then we multiply 3. So this part in here so it would work out to be 3. Then we multiply 3 by 3 because that's num3, that will give us 9. Then we add 3 more to that 9 and we get 12. Let's run that and see what we get for the answer. 12, at least in the case 12.0, because this is still set to real floating point number. Alright, so that is basically giving an idea of order of operations. Now people, remember that, and this is the reason I don't subscribe to saying right line, this times that, and so forth. I don't subscribe to that, because you guys as young persons, young programmers, aspiring programmers, I don't look at myself as students from the past CXC. Coding is something that I believe everybody should learn. It makes you a better mathematician, because now you're not only knowing what to do, but why you're doing it, how to do it. If you can answer those basic questions, what am I doing? Why am I doing it? How to do it? Chances are you'd figure out when to apply those principles and where, if, where, and when is applicable, or whenever they're applicable. Because many times what we find in math is a person just doing rote learning. Classic example, let me give you this as a scenario. If I say pi, let's use pi here. Let's say we're doing circumference of circles. And I put pi here as a const, because pi is always equal to 3.142 equal 3.142, or some person say 3.14 semicolon. Alright, when do you use pi? You're always using pi when you're doing circles. Why? Because pi was developed by saying the diameter of every circle can go around the circumference of said circle, of same circle, 3 times with a remainder of 0.142. Now, understanding just that concept of why we have pi and why the formula says r for circumference of circle is pi r, all right, times 2, all right. So it's pi times r times 2, y times 2, because double the radius gives you a diameter. And every diameter for every circle can go around its own circle 3 times with 0.142 remainder. That may add a little bit of a difference to how you perceive circles and their calculations and knowing when to use what. Earlier I had said that even in multiplication it matters. Let us say that we say here, so multiply by pi. Alright, and let's remove that. Multiply by pi. If this is set to integer, here's the problem. You're writing a program, sol is set to integer. Remember, sol is saying num1, which is 4, minus num2, which is 1. That gives you 3. Then you multiply the 3 by 3, gives you 9. But then you multiply the 9 by pi, which means 3.142. So here's the problem now. Let me make this clear, just for evidence. If I run this now, I'm doing multiplication, but the multiplication gives me a problem. Why? Because this sol is set to integer. And once I'm multiplying by a number with a decimal place, it's not likely the answer is going to be a whole number. That's not likely. So let me remove this, because I was formatting an integer. So let me remove that. So let some persons think this is the problem. So I remove that now. Now let's run the program again. Still get an error. So it had nothing to do with the formatting. What it had to do with is the fact that this is or should be real, and even if I don't format this, I get the same answer. Well, in scientific notation, here's the answer: 2 point whatever, which is not really 2 point, it's more like 28 something. But let's format this now. All right, colon 0 spaces colon, let's say 2 decimal places, just the same. Or let's go back to 1, because 1 was what we were using originally. And then now let's run the program. Program runs fine. 28.3. Alright, so I'm reinforcing this idea, young people. That is why when I'm doing this order of operations, I don't go telling someone for my students. I'm not saying that those videos that you see on YouTube not exactly correct, you know. Right line 4 plus 7, and then I semicolon and then run the program and so forth, and then you get a nice beautiful answer. So the 11 here, 4 plus 7, and then give me the answer. I'm not into doing this for order of operations, because as budding programmers, as persons learning to code, you need to get comfortable with using variables, and as a result making sure you properly declare the data types and knowing when to change a data type from real to integer. That's the main problem, and vice versa. So those are things I want you to remember. That is why we're doing it this way. I hope you found this video informative. I know we didn't do everything regarding order of operations and the whole BEMDA situation. We did a little bit of division, addition, subtraction. No exponents. We hardly use exponents, yes. And we use brackets. Alright, so that gives you an idea of how we do order of operations in Pascal. And all I can do is hope you take it to heart and don't take shortcuts. When you're learning, do not take shortcuts until you're comfortable with the how and the why to derive what. And I leave with this parting remark. Remember it, please. A properly defined problem is half the solution. Remember the steps to problem solving. Step number 1 is define the problem. A properly defined problem is half the solution. If the problem is not properly defined, you are going to make mistakes and make blunders. Alright? But of course, I leave that to your testimonials, and I'm not just preparing you for CXC to pass CXC and do well in CXC. No. I'm preparing you so that as you go out there into the world of work, and even if you're doing something on a program that somebody writes, you can say, no man, this is not right, something wrong. And you can go and check for yourself. You can write your own little program or your, when the time comes, your own spreadsheet and so on, and check it for yourself. And you can defend and propose the answer. Because if you know the answer to a question, but you can't let's say explain or defend your answer, why does it make sense that you knew? All right, so that's what that is, and I hope you enjoyed the video. Have a good one.